Let's see. Okay, looks like I'm live. Hello everyone, welcome back to the stream. So, last week we made some progress on the analysis phase, which is taking us a long time, but that's okay. Some of the progress we've made is on how we represent things, and we've started actually, well, the code is partially obscured, but we've started making progress on like going through the declarations and resolving them. I've been thinking about some of the things we've done last week, and I think there are some things we can improve. So I think this evening is just going to be about cleaning up some of the mistakes of last week and starting to make some progress on the rest of the stuff. We'll see how much progress we make. I don't think I'm going to be streaming for 4 hours like I have done in the past this evening. We'll see how that goes. Okay, let's get started. One big thing I would like to change. Last time I did this thing where I have a bunch of resolve function, which I'm probably going to isolate as their own group of functions, which is basically here resolve path is given some path info, which is like a identifier with maybe qualifiers in front of it and some type arguments, will give me the resolve version of it that points to the actual proper type or proper thing that it's referencing. And I'm using this resolve path that takes a big callback here so I can use it in different ways. For instance, when I'm trying to resolve a type, I'm doing a resolve path, and then I look at the result, and depending on what the declaration that's associated with that thing is, I can decide how I want to handle this. For instance, if I'm looking for a type, for instance, I have a name that appears in the return part of a function, I can do a resolve type, look at what that path is, if it points to a function declaration, then I can complain and say, well, that name is not a type. That kind of thing. However, there is a mistake I have made there, which is going to require a tiny bit of a change to fix. Resolve path, in turns, asks retrieve declaration to get the declaration. And we're back to the problem that has been plaguing this phase for a while, which is I have one structure that represents a declaration, and it is parameterized by the phase, the compilation phase we're in. Are we just done parsing, or have we actually done like all the analysis? Is it a resolved declaration? The problem is our dependencies, the things that we have imported from other modules, are all already resolved, but the thing within this module are not yet. We are compiling them. That's the whole point. This analysis phase is about resolving them. However, things within this module can reference other things from within this module. A function foo can call a function bar, which can call a function foo again, so they have to know about one another. How do we deal with this? And one option that I did not choose would have been to have a lot of the phase-independent data represented as an other data structure, so that I could ask regardless of the state, I want to know what your type arguments are, because like how many of them do you have, for instance, because that's not something that's going to change based on the resolving phase. But I have chosen to avoid duplication in the representation, and therefore we have one type, declaration, with like subtypes, type alias declaration, and so on, that are all parameterized by the phase. So at the moment, we have, in the context that we are carrying around, the declarations that are already resolved, which are the ones that are from imported modules, and we have the ones that are not resolved yet, the past one, that are from the local stuff in the module. However, when we do a resolve type, for instance, or resolve struct, like I need to know what that name points to, and it needs to be a type, I need to look at both what is already resolved, that may be coming from other modules, and I need to check what is but what could be the local stuff as well. And currently, again, resolve path does a retrieve declaration, and retrieve declaration right there only look at the local stuff. And that's because I'm gonna need something that is able to process either the unresolved thing or the resolved one. And again, another approach, if I wanted to avoid type shenanigans to do that, would be to extract some of the information to have them in a data structure that's not parameterized by the phase, but I would like to avoid having duplicate information. So instead, I'm going to try this approach, and like everything else in this project, if it doesn't work, we'll have learned something. But, I mean, it will work, that's not the question. If it proves to be unwieldy, if it proves to be the wrong choice overall, we'll have learned something, and we can go back on it. There's one aspect of it that I'm not convinced, but we'll get there when we get there. So I think, gonna introduce a new section here for the resolving stuff. And specifically, I'm gonna move retrieve declaration here, which I need to change anyway. But for in the analysis, I'm gonna change something. I'm gonna introduce a type class, and which is slightly inelegant, but again, I think that's the way that allows us to do something that deals with the declaration regardless of what state it is in, without having to duplicate information in new structures. Oh, I forgot to check. Last time someone told me that the camera frame rate is a bit weird, and I did not check that. Let me know if it's still weird this time around. I can have a quick look at the properties of the camera. It's supposed to be running at 30 FPS. Thank you. Yeah, last time apparently it was a bit like it was a bit of like lag isn't the right word, but there was a bit of like blur there. But it seems to be running at 30 FPS. It should be fine. Anyway, the thing I'm gonna do here is basically I want my callback on those resolve functions to be able to like take a declaration regardless of whether it's resolved or not. And also, hi, how are you? So what I'm gonna do is to do that, I'm gonna be able to say, well, I'm gonna take any declaration regardless of the phase, but to be able to do that, I need to have a class that states what do I expect this phase to provide. And this is the analyzable thing. We had a old version of the code that had a bunch of type classes like this. This is going to be a lot simpler this time around, because what we're going to need is very simply resolve declaration, which is going to be for a declaration at this phase, give me a declaration that is resolved. And of course, this is going to be within a monad, which is probably going to be this one as usual. And the thing is, we might not need to be able to resolve all declarations, because for most things, we don't need the resolved version of the declaration. For instance, if I am in a function and I'm actually like doing the type checking of that function, and there's another function call, I don't actually need to have the fully resolved version, knowing that, oh, this is a function that exists and takes those arguments, probably good enough. So we will see what we need, but this might not actually be required. We'll see. Because the big constraint I have is resolve, like this analyze declaration function will not allow cycles. If I'm trying to analyze A and then I'm trying to analyze B because of A and it requires A again, I detect the cycle and I error. Like, this is not allowed. The main use case of this is type aliases that reference one another. For instance, type alias foo that is a alias to bar, and bar is an alias to foo. We want to detect that. But we don't want to do that for functions or for some other things, because it's fine to call something else even if it's cyclic. So we will need to be smart about this. But this is going to be the rough shape of this. And I think I want to introduce already this one use case I have thought of where this is going to be a bit different, where for a type alias, I'm going to want to avoid doing type substitution after resolving. I think I want to be able, I guess, analyze rather than resolve. Resolve is fine, I think. Type alias, I think the difference is I will want to give it the local mappings, as in, hey, this is the type alias, but actually your arguments are this, rather than resolving the thing and then doing type substitution on the types within. So let's do that. That will be taking a type alias info, and that will give us, and I think the mappings, which are gonna be just name mappings. So they are gonna be the same mappings as we have here, which is I guess I can, for the argument to this function, just be a hash map from path to name. there should not be at this level a reason for a given path to point to more than one name. That's something that we'll deal with when we do the analysis. Okay. Here's the bindings of the things. Here's the type alias info. Give us the resulting resolved type alias info. Okay. And here we're going to need only two things. Past is going to be the interesting one. And the instance. And the other one that's going to be interesting is resolved, because that's the one that's the no-op. Resolved declaration is going to be trivially pure. Take the declaration, put it in this monad, because there's nothing to do. And a resolve type alias, we ignore the mapping, and we do pure on the type alias resolved. So that's easy. Past is where it becomes interesting. Resolved declaration is the analyze declaration function that's right there. Which I see here requires a few more things. Oh, this is annoying. Okay, there's an issue here that I hadn't thought about, which is in here I keep the location of the declaration that is passed, because that tells me where in the file it is, which I don't have for a declaration resolved. That being said, I know how to fix this. This is gonna take a annotated declaration of at that given phase, which for a pass declaration will contain the location, for resolve declaration will not. Okay. And I don't know if I will need, for the type alias, I will need the location or not. I'll have to think about it. I might just comment this out for now, so that we can see how that works in practice. And I guess this, as a result, also needs the name. Okay, so this ignores the name and does a pure. Perfect. Now, I can change this retrieve declaration, which is wrong. There's also another thing I want to change. I'm bundling several changes at the same time, which is always a bit of a risk, but what I want to change is here in those resolve path and the resolve struct and all of those resolve things that I'm going to actually bring back to this group here above. All of those, the callback expects is like takes a maybe declaration, because I am handling the case where the declaration was not found. That case at the moment only happens for built-ins, and I think I want to change that, because I don't think it makes sense to just say, oh, well, if the declaration isn't found, that means it's a built-in. I think that it introduces more checks, because I have then to check, well, I didn't find the declaration for this thing, was it a built-in? I think it's better to instead have a declaration, even if it's a special one for built-ins. That way I never have to handle this case, and I never have to handle the maybe here, and I can have my callback always take the declaration. If the declaration is not found, that means the name wasn't found. Or I guess it means that there is an internal compiler error, because if the name was resolved but the declaration, there was no declaration associated with the type. Actually, I already handled the case where the name was not found. So if there is no declaration, that means it's a guaranteed to be a built-in. But at the same time, I will want to do some checks with built-ins. I can't just say, oh, there's no declaration associated with them, because if I did not have any declaration associated with them, I would not be able to know, for instance, how many type arguments a given built-in type takes. And therefore, I would allow the int parameterized by int, which is absurd. So no, I think I'll change that. I hope my voice is soothing enough that it works. What time is it for you? Is it you're in Germany, right? So it should not be that late. So yeah, I think I'm gonna change that the built-ins do have an associated declaration, which means my callbacks 6 a.m. Okay, so you're not in the country. Oh, okay. So you're not in the country where I thought you were. And yeah, being up all night until 6 a.m. Yeah, no, I will not blame you if you fall asleep. So yes, I think again I'm gonna associate a declaration with all the built-ins so that my callbacks can like always guarantee to have a thing, or that the error handling will guarantee that. So let's go back to resolve path and retrieve declaration. I put them on the top. Here, retrieve declaration will have to change because it's going to be the part. I think I'm going to need to inline it in resolve path because it's going to require knowing the callback. So this callback is going to be, I'm almost tempted to introduce, monad stacks are like a big conceptual jump from just learning about monads. I I am on the record saying that I don't think monads are that complicated, and I stand by it. I think they're poorly taught, or rather, they're often taught from the perspective of people who have learned them from a mathematical perspective, not an engineering perspective. They're not that complicated, is my point. I will die on this hill. Monad stacks amp up the difficulty a bit, for sure. Like conceptually, it's like, oh yeah, well, this effect and we combine them and it does both is not that difficult, but some of the implementation details can be tricky. So I think I'm going to introduce a type alias just for convenience, which is ironic given that type aliases are the things in my language that are giving me trouble there. For this path callback, just so that it makes some of the functions. That being said, there's only one function that actually needs it. I don't know. So what do we need? This is going to be for all phases, such as the phase is analyzable. And this callback is going to take. So the path info resolved, I think, is important. A declaration at a given phase P that might or might not be resolved, and return as usual. Yeah, I think that's correct. Now, we're going to need to bundle this in. So we try to get the name that corresponds to that path in the current scope. So foo in this scope points to the local variable foo or to the foo type at the module level, whatever. We handle maybe, which is basically we throw an error. No, my type system is going to be a lot simpler. Because we're working with since the target language is extremely limited, we're going to be working with a much simpler type system. Like Pete doesn't even have floats, so all numbers are integers, which like makes a lot of things a lot simpler. Yeah, it's a thing. Like it's the thing I'm on the record saying quite a lot, which is they are a pretty practical programming construct, and if you view them as such, they're not that complicated. They're just a design pattern, if I may use a swear word. So here we have resolved the name, so we know in the scope what the current name points to. We have handled the error, so we'll throw an error to the user if the name wasn't found. Like, hey, you've tried to name a type bar that doesn't exist in the context. If there is more than one match, then we have to report an error as well. Like, hey, you've said that this is type foo, but there's like more than one in scope. Which one do you mean? On the side. Then this is going to be resolve type, which is this one. That makes sense. We need the parameters to also be types. Parameterized type, but no visible quantification. I am not sure what you mean. That being said, I am not entirely sure, I'll say, what the Hindley Milner type system is, despite using it in Haskell. Like, I'm not sure exactly what. I'm gonna do something. Yeah, no, I'm not gonna be doing anything that complicated. I'm gonna. This is gonna be a lot easier because again, our target language is so simple. There's no pointers in this. There's no pointers. There's no floats. There's no dynamic memory allocation. It is purely a stack-based language that we're targeting. So the type the like generic functions are just here to like remove a tiny bit of boilerplate. That's about it. So no, definitely not a complicated type system. Okay, here, what I wanted to do was, here is the thing, where I'm going to inline the retrieve declaration to avoid having to copy this big thing here. So this is going to be, either I find either I find the declaration as in we have already resolved it, either because it was in the same module, but we've already resolved it, or it was in a dependency, and we can process with the actual resolved thing, and that's going to be a lot easier. Or we don't, and we have to look for it in the locals. So let's do this, which is going to be resolved declaration using context declarations. And what we do on this hash map is a lookup of the name. Now, and I guess instead of doing this, I can just do this into case. If that's nothing, then we have to do the other case. However, if we did find a declaration, we can call our callback process declaration with this declaration and the path info, which I'm gonna resolved path info is just that. And in the case where we didn't find a resolved declaration, then we have to try to look for it in the unprocessed local declarations. And I'm gonna do this explicitly again. If we find just a declaration, there again, we can do the same thing. If we don't, then this is an internal compiler error. That means somehow we end up in a situation where, oh yeah, of course, this name points to that thing, but we have no declaration associated with it. That's an error. I don't have yet a mechanism for internal compiler errors that like tries to give information. Let's just do an error here for now. This, however, is a change compared to how the code was before we started this evening, because that means everything must have a declaration, and for now, built-ins don't. So if we try to resolve a built-in type, this is going to blow up. So we're going to have to fix this. Okay. Now, let's go to resolve type. Resolve type is gonna be a function that, given a path, so name and potentially type arguments, will give me the resolved version of this that points to the right underlying type, and will also check that the name actually points to a type and not to like maybe a function or a constant or something like this. So it is basically this resolve path to which we provide a callback that check that the thing is a type. And why do I do this with... No, I think this is correct. Resolve path takes the callback and the path info. Yes. Okay. So here, the big difference is this go function is a callback that, as stated here, accepts any kind of declaration, resolved or not. And we have the analyzable constraint, which means we are able to resolve the declaration if needed, which I might change this function here. I'm not convinced it's the right approach, but this idea of we take any declaration result or not and we resolve it on the fly if needed is, I think, the right approach for what we're trying to do. A lot of things don't change here. What changes is now everything has a declaration, therefore there is no need to match nothing here. So I can remove all of those closing parentheses. Here we have the same thing. If we find a constant or a function with that, like if that name points to a function or a constant, we can just report an error because that's not a type. If it's an enum, here we perform some basic checks. Here, very simple. If there's any type arguments at all, then it's incorrect type parameter count because enums don't take type arguments. But otherwise, we did find the enum pointed by this, so that's all fine. And if it's a structure, we check that the number of type arguments is correct. We don't do any instantiation at that point, but I think for structures, our type system is so limited that there would not be... I mean, there would be wrong ways to instantiate things, but it would be ways that are like, for instance, instantiating if a structure A is parameterized by a type T and contains a field of type T and we instantiate A with A, that's just not going to be possible to do because it would need to be A of something. Like, yeah, I think this is fine. And if we need to do more, we will do more during the analysis of the structure and during actually proper instantiation. Okay, so I think this is good enough for now. Now I think type aliases is the interesting one, and it is the part where we might need to call one of the analyzable method to resolve to guarantee. So we have here a type alias declaration with the type info, which will be parameterized by the phase in which we are. As a reminder, for me as well, a type alias info is this, and the name, the parameters, and the path info, as in like what does that point to. So here, basically, what we would like to do is resolve the type of this. Do I need... Do I need to do analysis of the type info to do this? Or is it enough to just... This one has been tricky. Basically here, this is, I am trying to see what the type foo is so that I can have the proper underlying type so I can do type comparisons like, hey, this function returns a type bar, and I want to check that like this variable in which it was, like, I want to type checking basically. But I found that this foo thing is actually a type alias, which means I need to be able to figure out what it actually points to. Here, I guess I could just resolve type recursively. I think that's probably just the right thing to do. The problem is resolve type takes a past thing again, which I guess I could change. Do I actually need... This case is tricky. I think no, what I need here is I need to know what the declaration of this thing is. I need to, like, whatever that thing is, I need to be able to look at the fully resolved thing, which will be calling resolve type on it, basically. But I need to only do that if it's not a resolved declaration yet. And since I want to be able to detect, yeah, I think the thing to do here is to do this analyze type alias thing. I think I'm gonna just do it with... Yeah, I think that's the right approach. So let's do this. I'm gonna remove this for now. I'm gonna add stuff as I need it as I go. So we need... Okay, I have found a type alias info, and I need to know what it actually is. It needs to be resolved. The only thing is, if I do this, and if I do something specific for type alias, then I'm not calling the big analyze declaration wrapper thing, and therefore I'm not handling cycles, and I'm not doing all the mechanics properly. That is a problem. So maybe what that means is really that I need. Because what I'm trying to do here is if having something specific for type alias means I avoid having to do type substitution, which I was like trying to avoid. But I think the downsides of avoiding are definitely outweigh the benefits. So I'm gonna instead go back to this version. Oh, and there was one big thing I need to change, which is that this is an annotated declaration, which means it will contain location information in the case where it's not resolved yet, and will not contain location information in the case where it is resolved. There we go. Okay, so that means that here I'm going to need to name the declaration here and the case declaration of, so that I have access to the full declaration. And here, basically, okay, that's a type alias. I have no choice. I need to recursively go through this thing. Resolve declaration. I will need the name, I think, which is the path name. And I will need to give it the declaration. And now I have fully resolved this type alias. If it, the only case where that happens is basically this type alias here in this function, in this module, points to another one within the same module. That's the only case where this is going to happen. And if there is a cycle, this is going to be detected by this resolve declaration that calls this analyze declaration thing. And it will also update it in the cache, which means next time we make a reference to the type alias, we will not need to actually re-resolve it again. Now, what we need to change here now is this is where we need to perform type substitution, which is tricky. So I think this is still correct, as in we've resolved and it points to, actually, is that correct? Yes, I think this is correct, except where does params come from? It comes from... Where does it come from? Oh, from here, of course. So what this is saying is basically here when we're calling... Yeah, of course. So this is a type, the type that we are pointing to, like we are trying to resolve a type that is in the scope. I said foo something, and this foo thing we discovered is a type alias. Here what I'm checking is I've called it with 3 arguments, and it's expecting 2 arguments. That's a type mismatch, therefore we can report an error. Now, here is the tricky part that we haven't done, which is I need to do type substitution because this within the type, like basically I'm going to be, if I have resolved the type alias, say that foo of t is actually vec of t underneath. If I'm calling, in this context, I'm calling foo with int, I need to resolve that to vec of int. I need to perform the substitution, which means for all of the names of the variable in the alias, I need to associate the values that are given to me in the path info. I need to do the type substitution. I was hoping I could give the types to the analysis, which would avoid having to do a post-processing, but I think that's going to be too complicated. So that means that now I am going to need to resolve this. So that's going to be actually, do I need to do that at this point? Do I need to do that at this point? Maybe not, actually. Wait, no, I need to do it at this point because I want to be able to compare things that in a way that makes sense. So I need to be able to say. So I need to do it to be able to do the translation. Okay. Let me think about this for a second. This is gonna be the resolve version of the type info. So this is still a type alias info that tells me, hey, this is the name of the arguments, and this is the corresponding type with the arguments given to it. So what I will want to do is ultimately return, oh, the type pointed to here is the underlying one. It is the thing within the info we have returned. This is what is being pointed to, which is the alias value here of the info. That's what we want. However, we are going to want to do the substitution, which is to say, here the arguments in this thing here, if there is an argument named t, this will contain references to type parameter t, and I need to change those to be the values that are given here. So now I know that the number of arguments are expected and the number of arguments that are actual, the arguments given are the same. I can just do a basic zip of the two things to get a list of pairs to get a mapping. Which means I can do type arguments, which is going to be a list that I'm create a hash map from. And I'm going to obtain, which is just actually a zip of the keys are going to be the name of the arguments as they appear in the type alias declaration. So it's going to be those. Zip alias params with of the info, of the result info, actually, that's important. And the values that we're going to associate to that, as in the type parameter t actually points to, and that's going to be stuff in the path info here. Original is not a great name. Let me just check what a path info is made of. Yes, params. Oh, they need to be resolved. They are going to need to be resolved. Oh, I guess this is the resolved. I don't need that then. That's the part I keep getting confused by. This first argument here is the resolved version of this. Okay, so that means the values that I need are the ones that are present in this path info here. And since I have used this syntax to have access to all the fields, then the values that I need, where's my hash map? There we go, is just the path params. Okay, so now I have created a hash map from the name of the arguments to their actual resolved value. This is now, I'm going to make it in another function, but this is going to be a substitute types with those type arguments as the first argument to this function, and I'm gonna give it the alias value here, and this is gonna be what this function returns. I'm gonna write it here, I might move it later. This is gonna be substitute types. It's gonna be a function that takes, for now, it takes a hash map from identifier to path info resolved, I think. Because the params, yes, that's what they are. And it takes a type alias info, which is a path info as well, which is a path info resolved, and it returns this. Now, so we have our mappings, and we have a path info. I think, unless I'm mistaken, that the only place we need to do the substitution, path info, there you are. The name is already resolved, does not contain stuff that needs to be resolved. That is therefore only in the arguments. Yeah, the example I would have, let's write an example. Oops, what did I change? Why did I have changes here? Yeah, okay. The example that I have is, I have a constant that has type, let's say, bar of int. And in the same file, there's a type alias where type bar of t is a vec of t or something like this. So now I'm trying to like resolve the type bar of int. I found that bar is a thing, it's a type alias. Therefore, I have resolved bar, I have analyzed bar, I've put it in the things that are already resolved as part of this module. In doing so, I have arrived at the conclusion that it is a path info of vector of t, with t being the type argument of bar. But in this context, where I'm resolving the type, I know what t is. It is int, and therefore I need to substitute that to be vector of int. And that means that here, given some mappings and a path info, which again contains path info. There we go, contains a name and parameters. The result of this, do I have lenses for path info? Yes, because I just want to apply a function on the parameters. I don't need to actually do anything on the name. So actually, this is gonna be on the path parameters. Traverse go, I think. Let me think. This is a function that takes, maybe this is just that actually. Okay. What is going to be? This is something that I take one of those path infos. So this is just going to be recursively substitute type, which means that here I need to be careful. Yes, it's not that simple. Okay. Because here I first need to check if the name of this type is actually one of the things within the hash map. Okay. So this is path name. And the name is for now one of those. I think the only one I care about here, I don't need to check everything. The only thing I need to find is type parameter with a given name. That's the one that is interesting to me. Any other case, we've already resolved that it's a type. I don't need to manually check. It's not like a built-in function or anything. In all of the other cases, I don't need to perform any check. I don't need to change the name in any way. I can do what I was doing, which is to return. So this is going to be info. I'm going to apply. Oh, I'm going to just path params of traverse with substitute types mapping. And I am applying this on the info, and that gives me my result. However, if I am in the context where this type points to a type parameter, then here I need to do a lookup of that name in my mappings. If I don't find it, what does that mean? I think that's an internal compiler error. I think this is something that should not happen because I have already resolved that type, which means that at the time when I was looking at all the types within the thing, I did find that there was a type named T that was part of the arguments. So if now I can't find it in the mapping, that means something went wrong, and that's on me, that's not on the users. So that means here I can just, on case with nothing, that's an internal compiler error. We don't have a proper mechanism for those yet, but we will have at some point. Now, if we do find a mapping, which is the expected case, we do have the proper we do have what would be the arguments? Aha, here, okay, this is tricky. So here we have the actual path info. I'm going to extend on this example here because it is not an easy one. What do we do here? So this case is I have this. I have something that points to bar, let's say bar vec, because that might be, that's allowed, that's perfectly fine. Vec is something that points to a name. Actually, no, I don't think that's going to be allowed. I don't think it's allowed with the things as they are at the moment. I don't think I'm allowing this. This has to be a proper type, so no. Something like this where like bar of t ends up being t of int, I don't think is currently allowed by our language. We don't support like other kinds than just actual type there. So I don't think I have to handle this case. So when we find, since we don't support things of kind, like we don't support type constructors as argument, that means that at this point, I know that the arguments here are empty. I don't need to continue resolving them. And that is something that here, as part of analyze type alias, will be done because type aliases won't have declarations associated with them. Maybe my thing earlier about everything needing to have a declaration is not something that's always gonna be true. Huh. Okay, so maybe I have to change that. But that means, as a result, that yes, there should never be okay, there we go. That's the problem. Okay, so what I'm trying to figure out there is, would this be allowed? Sorry, not this one. That's the older comment, so not this one. Would this be allowed? And I think at the moment it is. Because here I would substitute t with the name that points there, and since there's no declaration to match against, I would simply accept it. That means I have to decide there again what I want. If I want to allow a name in scope to not have a matching declaration, or if I want to extend the declaration type to allow for some things to have a associated declaration. And for instance, for type aliases to have a declaration, or do I actually don't? Maybe it's fine for type alias to not have a declaration, and therefore the number of arguments is not checked, because t can be anything, therefore calling t with one argument or more than one doesn't make sense to check until we know what t is. And here we know what t actually is. We have its arguments, and we can perform substitution on it, I guess. Yeah, I think that's the proper approach, which means I'm going to have to go back here and say that this takes a maybe annotated declaration, which is an absolutely horrible type. I'm almost, again, tempted to introduce a new type for just for this. But it would be only used once, so that is maybe not useful. And here that means I don't have to handle this with a nothing. It is fine for something to not have a declaration. And if there is no declaration, therefore what type it is doesn't really matter. Yeah, I think I can just do this. Okay, so back to this. So here we are back to, if this is nothing, there's nothing to do. I return the path. And all of those now have to be wrapped to be like, no, we did actually find something. Which is what I removed earlier. Okay. Okay, so now we're no longer going to crash on built-ins not having declarations. We will still want, I think, at some point to have built-ins that have declarations, because we will want to be able to do like checking on a number of arguments and stuff, which we cannot do at the moment because there isn't a declaration to check them against. So now we can go back here. We got the actual info. So we know that T is pointing to vec or to whatever else. And we know, and this is, we have, aha, no, okay. We will not allow vec here, because here the arguments have been resolved by this. We have resolved type every single argument, and resolve type will check that they are actual types, and therefore that the type arguments match. Meaning here, we don't allow this at all. We know that everything is just a type, a concrete type. Is that something we want to change? Do we want to change that so that this would be allowed? We control the language here. We could make that change. Wait, am I saying something wrong? One sec. I have resolve type of, so I have called this very resolve type I'm actually writing on the arguments. Yeah, here I would check, oh, this is actually the vec structure, and vec takes more than one argument. Therefore, it cannot be used as an argument to, it cannot be used as an argument to another type because it is itself not a type. Yeah, okay. I think I'm okay with saying that the language doesn't allow this kind of like higher kinded stuff, where a type argument cannot be an actual type, but a type constructor. I think I'm fine saying this is not allowed. If it's not allowed, that makes things simpler for now. And we can always change the language later if we decide to change that. For now, I'm perfectly fine saying that's not something we allow. Which means this actual info points to an actual type, which might be vector of int or anything like this, but it means it guarantees that here when we encounter t, it doesn't have type arguments, because that would not be allowed. Or would it be? Could we end up in a situation where we have something that is not allowed? So for t to have arguments, it would mean that when we have resolved it, we have done the type alias analysis, we didn't find any declaration associated with the type. Okay, so it is possible to encounter t with arguments here, which is not something that in practice we will allow. Because here, when we perform the check, there is no associated declaration with the type. Therefore, we're just saying, oh, t is the type parameter. We've given it the argument int. That's perfectly fine for now. That's not something that we're gonna flag at this state. I guess if we wanted to allow this, then it would just be a matter of changing the resolve type here to be able to distinguish, oh, this type argument might, like type arguments are treated differently than types. Therefore, here we would introduce something else than resolve type, but resolve type argument that would be slightly different and would allow mismatched number of arguments, so that we could support, because the arguments would be resolved at a later point, basically. As in, we would allow type constructors rather than types to be given as arguments. We would not treat every argument as an actual type. What makes me hesitate is we have to handle this case here. We have to look at, okay, we've resolved the type. It is T was actually pointing to this. And now here are the arguments we're giving to it. We have to handle this case. So might as well try to see if we can handle like higher kinded type arguments while we're at it. Or decide that we don't care again. If we don't care, it's a lot easier. Yeah, I think for now, I am not gonna worry just because I want to make progress. So at the moment, it cannot happen anyway. There cannot be arguments here because that would just simply not have been that would have not type checked at this point. So we can assume that the arguments are empty, and therefore we can just wholesale replace T or whatever the argument is by the actual info. Which means I can replace this by a simple lookup of the mappings, and on nothing we can handle this with a nice, because this is not something that can happen given the type checking we have done. And that should be all, given that we don't allow this construct. Okay. And now that should be everything for resolve types at long last. Let's see why I needed resolve struct for something else. Yes. I'm gonna keep you separate here. We're gonna have probably one of those resolve per type of thing. We're probably gonna have a resolve function, a resolve const, like having a bunch of things like this where we're gonna need to be able to resolve a thing to know what it is. For struct, this hasn't changed. Aha. How much of this will we need to duplicate is the thing. Okay. So here we're trying to get, we have the name of a type, and I want to check that the name of this type is actually a structure and find the corresponding structure. And I need that because I will need to be able, I might even want to return the actual declaration here, like maybe path info resolved and struct info, actually. Because this is going to be required for, the only reason I will need to know that something is a struct is within a function, like this function is calling a struct construction expression, which requires knowing about the struct, therefore it needs to be resolved, which means it's going to need to be resolved first, but the resolved struct will not depend on the function. This is all fine. So here I will probably want to return pure path struct dec info. But how do I handle a type alias? I guess I'm going to have to do something somewhat similar. Yeah, I guess we have to do basically the same thing, which is a bit of a duplication, which is a tiny bit annoying. Which I guess I could. Wait. I'm thinking about something else. Here I do the resolve declaration, which means I have found what this type alias points to. But it could be pointing to a type alias. That's still a thing that could happen. Do I need then to continually recursively do that? And I think the answer is yes. Wait, no, I don't. Because the whole point of doing the full analysis of the thing is that it will point to something that is not. It will point to something that is no longer a type alias. So as long as analyze type alias here does its job, it will no longer point. This is where we're going to be doing this. Okay. So no, I don't need to do this at this level, which means in the case where I'm looking for a struct, I can do this duplicated version, which is not very elegant. Actually, I could go one step further. I could avoid doing this and have this return the declaration resolved. Which means here this returns. This gives me the resolved path info. And my function overall returns this and the declaration. In the case of an enum, likewise, and in the case of a structure, likewise. And now I don't have to duplicate all of this. I can do resolve struct is a resolve type with the path info, which I think I can just write this resolve type into a function that takes the result of the previous one and will return something in the monad. And that is going to be a function that to a path info and a declaration does a case of the declaration. And if we find a struct declaration with the info perfect, we return path info and the struct info. Otherwise, if we find anything else, we can instead report an error which is going to be error not a struct, which points to the path info and I guess the wrong declaration, which we need to add to our errors. Error not a struct. I guess I will need to have path changes into a bind, and here I can therefore use the path name of the original path so that I have here a path, excuse me, like I have in every other, like that will basically be the identifier that is wrong regardless of how it actually, what it actually points to. And here I will have a declaration resolved from which I'll be able to do an error message that says like expecting a struct found whatever this is. Okay. Okay, so now all of this should be fine. We should be back to a point where we can do some of the tests we were doing 2 weeks ago, which is good. There's a typo here that might have been here for a long time. Now the big thing is I need to make sure that analyze type alias actually will this always, if I have, I guess I can test it actually. I can probably test it. I think it's correct now because this will call resolve type, which will call analyze declaration again. So in theory, we should never have a type alias that points to type alias after being resolved. That should be fine. Which means we can go back to analyzing constants after we're done with this. Okay, so first let's try to build this. Let's see what's wrong. It's not, excuse me. It's not resolved, it's resolved. Aha, so maybe I am gonna need to, if I make this explicitly like this, Go has this type here, is the compiler happy? Ah. The problem is annotated. Hmm. I never how to remember how to resolve those. Okay, let me fix the other errors first. Oh, I guess it might require. Yes, I might simply require, and I can put it here. It might require, if I go back to my AST, for annotation to exist, then there must be an annotation instance. So there must be an annotation declaration of P for this type to be correct. I think this might be the problem. In which case, I'm absolutely gonna be annotation declaration of P, analyzable P. I'm gonna make some kind of type IS for this then. Still no. Where are you unhappy? Here, giving Go as an argument to resolve path. Expected. That's extremely annoying. I do not remember how to do this. Basically, I'm writing this as like, this needs to accept a for any p that matches this callback needs to accept this, which is perfectly fine, and this function compiles. But here, when I'm trying to call it with a callback, it does not work. Despite the fact that I do have the for all in there. Is it because the for all needs to be at a different place altogether? I do not remember this well enough. Rank n types, let's go. I think this might be it. Let's try that, which means I'm gonna move this to here. Okay. Couldn't match. Maybe annotated declaration P with path info passed in the second argument of resolved path. Oh, it's probably because I have the wrong number of parentheses somewhere. Okay. Are you happy now? Okay, I am gonna introduce a type IS for this. So we take path info resolve. Wait, actually, it's the. Yeah, that's correct. Followed by this thing here. And we return this. Okay. Again. Now this is a resolve callback. Are you happy with this? Aha. Yes, here this needs. I have found the thing, so I'm going with the non-maybe version. Therefore, to have it twice a year. Yeah, I do really. I've started doing Twitch stuff only for the advent of code. This is my first time doing like a non-advent of code stuff on Twitch. It's supposed to be a like much longer term project and a bit more ambitious because it's not like problems that are designed to have one clear like yes or no answer basically. But yeah, I do like the advent of code, and more stuff like this would always be welcome. Okay, so are you unhappy now, and why? Couldn't match. Annotated declaration P with declaration resolved. And I guess this means I need to tell you explicitly this is an annotated declaration resolved. Thank you. I'm thank you for saying this. Oh yes, of course. This is a maybe annotated declaration resolved. The problem of annotation not being a non-injective type family is that it forces a bunch of annotations absolutely everywhere, which is this is a thing that I don't know how to resolve. This is extremely annoying. It should be fine for me to say this is a resolved because this takes any random, well, any, not random, any p, like, I guess I need to, but no, that doesn't make sense. Oh, I know how to solve this. I know how to solve this. Not gonna do it this way. Rather than saying it needs to take a callback that works for anything that happens to be an AST phase that has this thing, which is why I'm struggling that much, because it's gonna need a bunch of type annotations because of the non-injective type family. There is something a lot simpler I can do, which is that instead of analyzable being defined on the phase, it is defined on some arbitrary type A that is given here. I don't think it would be good at it. LLMs are famously pretty bad at handling large code bases. And I don't know if there is a lot. Right? There are a lot of Haskell compilers out there, so they would have some Haskell compilers in their training data. But I'm not convinced that there is anything like what we're doing, so there would not be any close thing in their training data. So I don't think they would be good at it. LLMs are notoriously bad at large projects. So no, I don't think they would be good at it. I'm also notoriously extremely anti-LLM, so you're asking the wrong person there. But yeah, I know I don't think they would be good at it. And yeah, I think if I just substitute this, then it becomes a lot easier. And I can now just say that this a with location of a declaration passed is analyzable. And it becomes the same thing. And here I can say the same thing for a declaration resolved. Therefore, the annotation problem goes away. There's no longer any annotation here, which means here this type alias is no longer really needed, because this becomes not a monstrous thing like this. It becomes for any type A that happens to be analyzable. And I can probably then simplify a bunch of things. There we go. Because now annotation doesn't no longer appear in there. And I probably no longer need this type alias here. This type annotation here. Okay. And I can probably therefore remove this to be back to being the way it was before and inline it back here. Actually, I'm going to keep it not inline for now, just in case, but this is a for all A. Oh yeah, I understand what was wrong, but now this should be a lot easier with the type family being removed from this. Just gonna put it back because this is temporary now. I think I'm not gonna need the type alias to make this work. Okay. And there we go. That compiles. And I think I can even remove this type annotation here, and it would still compile there. It doesn't. I was wrong. Okay, so I will keep this type alias here, and I might... Yeah. Let's do that. As I would a function otherwise. Okay. And now we're done with this part of the nonsense. So now we have very simple errors to fix, hopefully. Name not found. This error, incorrect type parameter count. I would probably need to have a path here as well, because it's expecting a name, which I suppose would be the path name in this context. Actual type declaration resolved. Interesting. Oh, yes, of course. Of course, of course. Here, the problem is I'm using resolve declaration to guarantee that I'm calling all of the mechanisms here of analyze declaration, which means I'm giving it a declaration there and I'm getting a declaration out. So here I'm going to need to assert that this declaration I'm getting out, I need it to be a type alias declaration because I am in the context of a type alias declaration. I have two options. Either here I'm giving it the full declaration and therefore I have to assert that the output is the correct type, which would be redundant work basically. I'm re-unpacking this thing to check and it's an internal compiler error if it's not, because that would mean that I've given it a unresolved type alias declaration and I got a struct declaration out of it. That's not possible. Or I have to change my functions here to be able to like do all mechanisms of an analysis, which is like what is done here before delegating to specific functions in all cases. And I would need to introduce more things in the type class. I think I'm going to choose the simplest option, even if it's not necessarily the most elegant, which is here. This needs to be a type alias can't type alias declaration. In which case we return just that type alias info. Anything else is an internal compiler error. I don't like having this path here because again, that's means we did something wrong somewhere else, and this could be avoided by having the function take directly instead the type alias declaration rather than the full declaration. But at least this is now correct, I think. Okay. Clean match resolved. Oh, yes, yes. I'm binding this in something that I therefore expect something magnetic. But here I am just doing a map. Okay. Oh god, are we back to this? If I inline this again, which I might need to do, maybe this type bias is a mistake. If I do this again, in this context, I have this takes any A that happens to be analyzable, which means here aha, that's the problem. That's why. Okay. This type is wrong. Okay, let me change it. Yep, this is wrong. Ah, this is annoying. This is again the problem of do I have the location or not? Because the problem I have here is I am making an assumption about the shape of this, which is it is a type declaration. It is a maybe of a type declaration, and therefore I can do this. But that is not true if it is a one with location. This is profoundly annoying. But this is solvable. This is solvable. No, I think I'm gonna have to go back to here, this being parameterized by the AST phase. Okay, can I make this work with the AST phase? So here, this is an annotated. So I can put here the constraint annotation declaration. P implies that P is analyzable because I can resolve the declaration, annotated declaration P, and that gives me the resolved version. And I will need a get declaration. Well, is there actually, it might just be part of annotated. Yes, I have within that will give me what I want. Okay. So I don't need to do more than this. So we're back to here. This is analyzable past. This is analyzable resolved. Okay, so this may be an annotated declaration of P, and here I'm going to need to change a few things. The process callback here, resolve path hasn't changed. Here, however, is where things are complicated, because here I am going to need to do and I think I'm not going to use this alias because I'm going to want to know, want to have the name in scope so I can use it for type annotations. Okay. All of that because I want to avoid having duplicated information outside of my AST types. Now, here, the problem is I'm going to need to use within. Within is a lens. I think this is therefore within. Okay, and this is probably going to require some annotations here. Yep. Oh, yes, okay. Traverse within, I think? Traverse dot within, probably. Okay, so still there. I guess to avoid having to do this complicated thing, I know this is a maybe, so I can do. Oh yes, here I'm doing the result declaration on a maybe thing. That's why I think this function having the wrong type is why I'm getting all of those like confusing things from the compiler. That's very confused what I'm doing. So, I'm gonna hide this. In the case where it's nothing, I can return pure path and I don't need any of the complicated things. However, in this case where I have just a declaration, then I can do a case declaration of remove the just here, indent this, remove all of those cases here, and now I think this is what was making it extremely confused. This should be better now, hopefully. Because now here, indeed, we're calling resolve declaration with not a maybe declaration, but the actual declaration. and therefore this is probably going to be fine. The only last thing is here I need to do this within. Okay. Hopefully now, nope, still the same error here. Frustratingly, but maybe that's because couldn't match expected. Oh, because yes, because the callback here, I've said yes. Okay, I've said that I need to change this callback to match the change we've made. We've made the change. We've changed this to B. Actually, does declaration resolved make sense in all cases? It probably doesn't make sense in a bunch of cases. So maybe I can't do that. Okay, so I think I'm not going to do that. So I'm going to remove it from here. Which means here I'm going to have to do resolve struct. I'm going to keep resolve struct that way with the struct info because that's going to be useful, I think. Unless it makes no sense. No, I think it makes sense to have it as part of the resolve struct. I'm type checking something. I need that. Oh, unless I keep it separate. And this is like, yep, nope, this path info points to this particular structure, and then actually checking that this is a proper struct declaration comes later. Nah, I think it needs to be part of this. Which means this is going to be something we finish later, but there's going to be resolved path is going to be the result of calling a resolved type, which means we know it is we know it is a actually maybe it makes more sense to do this with a callback so that I can do. Yeah, okay, I think I'm going to rewrite this function. So for now, I'm going to comment it out. Because I think instead it's going to be better to use a callback like I have for resolve type. Okay, then that means here, whenever I return a tuple, that is no longer required. Which means all of those was also creating more confusion for the type, which is no longer therefore going to be a problem. Okay. Will this be enough? Nope, this error is still there, but is it because there is more errors to fix? Probably. Within is unhappy. I have used within in the past with qualifications. What did I do to do that? Okay, so that's going to be this. This is within with type applications saying this is a declaration at phase P. Okay, there we go. Next. Resolve declaration. It's unhappy about the type, but that's the one here. I guess it's all because of the annotation thing not being injective, so I think I might need to do this again. Okay. Ah, this is what I was afraid of. The rest of the function is not correct, and we still have this error. That is extremely annoying. Wait, where do I need resolve struct? Because since I don't want to do it now, Yes, is a bunch of undefined and to-dos. I think I'm gonna copy this for now. I'm gonna comment this out for now. Okay, so the only thing left before we can test our type alias thing and our type substitution is to finish figuring out this error. And now process declaration at past. Okay. So now this should all be good except for this error that I don't know how to fix, which is very annoying. What bothers me is it is probably just a matter of syntax. Because this function works for any AST phase. It is explicitly for all AST phase. And I'm giving it as a callback that expects any AST phase indeed. So I can't give a type annotation here that makes no sense. Would it work if I were to say something like, this is getting some arguments. This might work, but this feels ugly. This is probably better. So I'm getting a path info. I am getting a maybe declaration. And I'm calling go with those two arguments, which means now I have arguments here. This thing happens to be... No, that's not probably not gonna work. Yep. That's because of the annotation. That is extremely annoying. There is a solution, I guess. But it means changing a bunch of things. I suppose an easy solution to this, which stems from the fact that resolve declarations do no longer contain their location, would be to continue keeping the location of everything. Which means when I finish compiling a module and I use that header information for other modules, I still have the exact location of where it was declared rather than this thing that was declared in the module with that location information. Which is probably better. But not the way I wanted to do this in the first place. But the problem of annotation being non-injective has been such a pain that I think I am going to make that change. This is going to break a lot of things, which is going to be annoying. This is fine. So here now, a resolved declaration is also still with location. Statements and things do not need to contain the location anymore, but declarations still do. I am once again wondering if trees that grow is worth the hassle. That means now that I'm gonna need to... I will have with location here. This is gonna break so many things. It's gonna be great. Another thing I need to change is going to be, so here now, resolve location no longer has the annotated. It's always going to be a with location, which makes it probably a lot easier. Okay. And now, hopefully, this is going to work. It's going to be broken in other places, of course. Yep, within is wrong here. It is indeed located in this context. Which means also that here I don't need to use within. I can use located. Okay. Oh, we're comparing the parser. That's good. That's a good sign. That's a very good sign indeed. Okay, and here, this is the initialization, which has module name symbols, which is here, which means I need to change this to be with location declaration resolved. It's a poor name, and we're going to have to change this. So this is going to need a with location here again, and this is going to require the location of the declaration. Okay. Arguably, it was a change that was going to be required at some point, because having the location of the things we import, probably worth it. Couldn't match with location. Yes, now this has changed. Expected. Okay. So here there's somewhere where I do the located thing and I shouldn't. Or maybe it's actually fine and it's just the type here needs to be adapted. Okay, where next here likewise this is going to be a with location. Okay. Expected. I suppose here it is pure of located. I don't need to, yeah. I just need to unwrap the location. Okay. What is wrong here? Wait, what's the error there? Oh, of course. If I do this, then I end up getting... Of course, I end up getting a with location, which means I will need to do... I will need to do instead a case if it's just a declaration, we can return pure of the located declaration. Otherwise, there we go. This is a big change, which is breaking a bunch of things. What is the problem here? The function located is applied to... So if I do find this is... add map with location declaration resolved. Okay, so that should be fine. What is wrong here? Oh, because here I am matching this. Arg. Okay. So here I'm going to have to rename this. This is therefore the location of the declaration. And where do I use located? And this is therefore located of the declaration. Okay. Next, what do we have? Resolve declaration needs to be inserted with the location. I guess I could store the location here, which is the location of the declaration. And therefore, this is with location this only used once. This no, actually, it's used more than once. Okay, so that makes sense. Dec location. Next, name shadowing. That's fine. Let me try now to do this, since now there should not be any annotation anymore. Defined but not used. That's the kind of error we like to see. And now this looks like it compiles. Okay, so the real problem was, as always, since the annotated type family is non-injective, it needs type annotations, which to give it as a function that expects any of them, and therefore needs to be able, like, I would not be able to have both something generating that takes any of them and also be able to properly forward type annotations, which means now I can probably remove some of those type annotations. Okay, yeah. Can I remove this one? Can this work without the annotation for the P phase here? I think it should. Nope, here it isn't clear. Okay. All right, maybe this one is not needed. Let's see, because if it's not needed, then I can use the resolve callback here. Okay, that's perfect. Okay, so when I keep this alias, that way this is a resolve callback, this is a resolve callback, and I don't need to keep a long type. Okay, and at long last, this compiles, which means I can go back to not this main, this main, and I can try to make it compile because this was our test program to test some of the cross-module analysis. So let's try this. So I just need to check that in analysis, the analyze module top level function, there we go, returns maybe symbols, which now contains locations. That should be fine, which means we should be able... Okay, perfect. Let's look at our test things again. Foo here has type bar is foo. Bar has the same. Okay. I'm going to remove this that I don't need. So what I want to see is what the resolve declaration there is. The only problem is I think, let me go back to analysis. I think as a result of... No, actually, it's probably fine. As long as I don't have constants or functions, I should be able to try this. Okay, perfect. So we import foo, which contains... Let's rewrite this. This is going to be a structure A4, and we're going to have A3, which is A4. I'm going to have a bunch of those. I want to check that all of my substitutions are working correctly. Up, there we go. And main is gonna say that its return type is foo, and I will want to check that the resolve thing is A4. Oh, and I want to say, of course, A1 here, and make sure that through the aliases this is working properly. If it does, I'm gonna make a more complicated test. Let's try this. Undefined. So we've hit one of the undefined. Analysis 257. Where is that? Oh, I don't have... I thought I would have done this at this point. Okay, let's introduce a very basic check of function. So this is going to be a function declaration of analyze function, this name and the info. And just like here, where it's going to be mostly undefined, this is going to be also mostly undefined because that we just haven't done this part yet. But we can do something that's correct even if it's incomplete. Because if we look at the AST, what is a function info? What does it contain? It doesn't contain a ton that needs to be analyzed if we don't analyze the body of the function, which we're not going to do at this stage, just because I want to complete my type alias test. So we have this function info that contains all of those things, and when I want to return the resolved version, And I guess for now, the only thing that matters to me is the function type. So I can return the fun name unchanged because it doesn't contain anything, the fun parameters because it doesn't contain anything that needs to be resolved. I'm going to say that the resolved version contains an empty list for the arguments, which is very wrong. The resolved type, which is the only thing that we're going to do at the moment, and an empty list of statements because, again, I just want to test the return type. Now, the type is the important part, and for this, what I'm going to want to do is resolved type, which is going to be a traverse of resolve type without the T and the D, resolve type of the fun type, which will give me maybe the resolved path, and there we go. With just this, hopefully, pass error here, because that's the wrong arrow. There we go. Couldn't match const info. Is that probably because I have kept a const info by mistake? Yep. Also, I forgot the type name here, function info. Okay. Let's go back to our test the second this is done. Okay. Okay, so that did compile. There's a bunch of things. What did I want to check? I wanted to check. So, okay, main. What am I pointing? What am I printing here? And I might want to change how it is represented. This is print symbols. So this is for each name. Okay, so what I'm going to do instead is for to list of the symbols, which gives me the name and declaration. Do print name and then print declaration. That way I'm going to have a tiny bit more spacing there. Something else I need to check is I need to have more than one function with the type A4 or something in it. That way I can check that once I've resolved it once, it doesn't get resolved more than once. Okay, so here, the symbols at the end. Oh, this is, yes, that's useless. Okay. This is a map from module, so that's going to be okay. I'm going to add a small helper function. Hello. Welcome to the stream. What I've spent most of the evening has been to rewrite some of the analysis phase of the compiler. Specifically, how do we resolve types and how do we deal with type aliases has been the main thing. And now I'm just tweaking in the small test program to be able to do some manual tests. I think the big thing I want here is I just want to render path, which is going to be given a non-empty thing, which I think is always going to be identifier. Give me a string, basically, and render path is going to be a to list on the thing, and then on which I do a map show, I guess, followed by an intercalate. I think I never remember between intersperse and intercalate which one is the one I want. Intercalate. So that would be a string, list of string, give me a string. Okay, so that's what I want. I want intercalate with this. Okay. So now I can use this to like render the module name. And now for every declaration within the module, I can do the same thing. Because each of them will be a hash map from identifier to location, which means here I'll have a with a location that I'm going to ignore and a declaration. And for each of those, I can therefore print indent name plus this. Actually, I'm just going to do it as a big print string, which is ugly, but again, that's fine, plus show the declaration. There we go. Okay, what is wrong here? Oh, just that a bunch of types are not in scope. I'm gonna need a few more things. I'm gonna need representation location, and I'm probably gonna need representation AST, I think. Ah. Okay, that's a small mistake on my part. Here in the editor, I'm compiling with test enabled, and here in the console, I'm compiling without test enabled. So switching between back and forth means I have to recompile a bunch of things, which is a bit slow, but oh well. And a bit useless because, okay, no. Identifier comes from, I think it's defined in tokens for now, which is not a great place for it, but that's because we recognize identifiers as part of the lexer. NE non-imported, that's because that's data list non-empty, qualified as NE. Okay. There's a place here when I'm using something as a string, but it is in fact text. Oh, because here I am doing name, but this is probably a show name that I want. The only thing is, if I go back to tokens, what's the show? Show of identifier is gonna be, it's not gonna be what I want. So I think I need to replace a few places where I've used show. Here I need to instead use text dot, and I can actually just use text here. And this is going to be unpack because I want strings for this test thing. And I can probably get rid of the import of tokens then. Map t unpack. And here likewise, this is going to be t unpack. Okay. is it because... Oh, god damn it. I have imported the print string of text in this scope. Why did I do that? There's absolutely no reason for me to do that. This at some point, this module will be the proper main that calls our compiler. But since for now we're nowhere near the point where we need this, I am using it as a small test program. There we go. We're down to unused errors. Name is shadowing. Let's do this. Okay, this is going to make reading the output of our test program a lot easier. Tests still pass, unsurprisingly. Let's try this. So, after compiling this small thing where we have foo that contains type A1 points to A2, A2 points to A3, A3 points to A4, A4 is a struct, and we have a small main file here that imports foo and has a function main that points to A1. In the module foo, we have here the resolve version, A4. Aha, they're not properly resolved. That's interesting. No, they are. Okay, perfect. A1 is a type alias that is resolved to point to A4. A2 points to A4, A3 points to A4. Therefore, my main is that was pointing to A1 is probably resolved to be the type is found to be A4. Perfect. And it is a top level declaration in module foo with identifier A4. So it has found the proper thing. Perfect. Now, let's test something a bit more interesting. First, I'm going to want to check something. I'm going to introduce a main2 function. And I'm going to introduce a type A equals A1 here and say that those point to A. And I'm going to change my analysis module here to check. I'm going to do a trace M. A trace show M actually should be fine. Of this name. I want to check how many times we resolve a given name. The point of this test is I should be only resolving A into A1 once. Because whether we do the function main first or we do the function main2 first, regardless, we're going to need to know what A is, which is we're going to find its type alias, therefore we're going to need to resolve it. But then, whenever we resolve the other declarations in the module, we should not be resolving it again. It should be cached properly. This would be good to have as proper tests, but given that we're so far from done with this analysis phase, I'll write proper tests for all of the error paths, I think, when we're done with this. This is just testing that we've done today. So this should... I'm missing one thing. Here in analysis, I'm going to be missing import debug trace. Oops. Let's try that. Again, since here I'm not compiling with test, it has to recompile a bunch of things, which is slow and a bit annoying, but that's what it is. Okay. Pass error. So we have resolved foo A and 18283 once each. That makes sense. Why do we get a pass error? What did I do wrong in my main file? Oh, this expects a semicolon. Okay. When passing the module main, we only do A once, and then both main and main2 probably point to A4. And A is indeed a declaration that points to A4. Perfect. Next test. Next test, I'm gonna copy what's in foo here, and I'm gonna put it in another file just because I want to be able to keep things separate. B4, B1, B2, B3. I'm gonna wanting to test type aliases on this one. Let's do use foo. So here, this takes some type T here. How do I do this? I want to check that the substitutions are working. So I probably want to do it with two types, T1, T2, and I have a field A of type T1, a field B of type T2. And I probably want to have several substitutions in a row, like maybe B1 has T1, T2. And it's actually doing, it's an alias to B2 of T2, T1. It flips the arguments. B2, T1, T2 points to B4 with B3 of T1 and B3 of T2, something like this. Something complex, something a bit absurd. And B3 would be B4 A1. No, it needs an argument. Do I just say it's B4 TT then? So that would mean that the B1 T1 T2 would be a B4 of a B4 T1 T1. Well, T2 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 T1. Yeah, something like that. Okay, that is ugly as hell, but this should test that we are doing name substitution properly. And now in main, I can remove this, say A1. This is my function 1. And my function 2 is gonna be a B1. Let's say A1, A1. The problem with this, let's introduce a new struct. Let's do C1 that contains an int. I don't have resolution. Do I have resolution of names? Do I know what do I have in my built-ins already? I have int so far. So let's say that is A1 int. Okay. Pass error in bar. Oh, I think I need the proper name spacing like this for arguments, which means I will need it here as well. Error not name not found T1. Yes, T1. Wait. Aha. So there is something wrong in the name resolution of type arguments. So I'm trying to resolve B3. We get an error name not found T1. That makes sense because there is no T1 in there, but there is not one here either. So what does that mean? Does it mean that we're trying to resolve before there and we are not doing it properly? That's probably what it means. Okay. So error name not found. That's doing a resolve path. Okay, that makes sense. So let's think about this. We're trying to resolve a type. We resolve type alias. So we're going to just call it recursively until we arrive and we do the type substitution. Just check this. Okay. Respond to that as soon as I'm done. Let's see. So here when I resolve the struct declaration, I am not doing... So I guess my problem will be in the substitute type thing. I have the trace already in this module. I'm gonna do something. Here, analyze type alias should be fine on its own. Because I'm only calling, yeah, it does not... Oh, there's a bug I haven't considered. Okay, it's not the one I'm currently seeing, but there's something I'm seeing that's going to be wrong. If I am analyzing a type alias and it points to a type alias that points to a type alias, I think the way I do this local here... No, I'm doing a union, not a union with, so I'm overriding... Yes, I don't have the warning, so that's fine. Okay. My concern with this was when we're going to be doing the analysis of B1, we're going to look at the analysis of B2, but T1 and T2 being in scope will mean that when we get here, is this T1 this one or this one would be ambiguous, but no, we won't have that problem. Okay, so that's not the problem we're facing. So I think the problem we're facing is purely a problem of... I was going to say it's only a problem of substitution, but we do not do a resolve type on the name substitution. So that's not where the error happens, which means it must be happening when I do a resolve type of the arguments. Because resolve path calls resolve type on the arguments. And that means that there's probably... Is there any other place where we return an error name not found? Nope, there isn't. Guess for now, just to see what happens, let's see when exactly we encounter this error. So let's run with the trace. int succeeds, a2 succeeds, a3 succeeds, a4 succeeds, b2. Oh, this is all the ones in the. Okay. So I'm doing b4 that has path name t1 in the params, and this, therefore, I do a b3 and has path name t1. T1 succeeds. I do b4 with t succeeds. b3 with parameter t2. Okay. Hmm. Why do I get this error name? Oh, I guess, haha, I do recover on errors. So that means the only call to T1 is there. Hmm. That's interesting. Let me think about this for a second. This is the kind of thing of having the location of like, hey, this is the thing I'm trying to look for and it doesn't work. My error handling needs some work, but that's not a big surprise. We knew that already. Oops. Oops. I didn't want to make these changes. Yeah, there we go. I think this is a problem anyway. I think this is a problem. This is not the problem we're trying to fix, but it is a problem. The problem is this. I am resolving a type alias, and I realize, oh, to know it, like I'm resolving a type, like the type of a function. The type of a function is a, and a is a type alias, which means I need to resolve the type alias. The problem with this is when I resolve the type alias, when I do anything, I'm gonna change this. When I'm resolving a type alias, I'm gonna change the scope of what names are in scope. And for the case of a type alias, for instance, I'm gonna say, well, the names of the type parameters are in scope for this. Likewise for, oh, is it just a struct problem? It might be just a struct problem. I think I figured out the error we're facing, but this is still an error that we need to fix. I'm saying, hey, in the names that are in scope, change the scope to add those names that are the type parameters. But since I'm going recursively from like, hey, we're doing this declaration analysis and then we're doing this one on top of it, we're stacking them because we need to resolve the function, we need to resolve the type alias, and we need to resolve the type alias. That means I'm stacking the contexts. And that's wrong. Because it means that if I have type x parameterized by t is y with t, and I have type y of u is I don't know b1 of u, this is fine. But since if I resolve x first, I will need to then resolve y, and I will resolve y with the scope of x, then this would work. And that is broken. So I'm going to need to change the way I put the scope for the type alias declaration. However, this is not the problem we're facing here. Also, I need use bar. I'm surprised actually this worked without it. Oh yes, because we didn't reach bar at all. The problem was indeed in the bar module. I should have realized this was not a main problem. And I think the problem is that when I do type resolving for structs, I do not do this change to the local scope. So if I look at analyze struct, where are you? Yep, here I do a resolve type on the type of the fields, but I will need to do this instead. Which means I need the declaration in scope, well, the info in scope, to apply here as an argument. And I will need to declare the type names. Which is probably going to be struct params. Okay. And with this, which has the same problem. So I'm probably going to want to introduce a function that fixes this. Which means I need to keep track. I need to keep track of the original scope context, the top level context, so that when I do the analysis of something, I can always restore the scope to its root context. So that if I am analyzing something in the context of analyzing something else, I'm restoring the scope to the context it was at first. Which is tricky, but it is the correct thing to do. Okay. But with this, I should be able to go back to this test. Except pass error on local. That's fine. Yes, this needs to be in a do block for this let to then go into the local here. Struct params is not the proper name. What is in a struct info? It is struct params. Is applied to too few arguments. Yes, that's because here I had. Yes. Here I was decomposing the type IS info, and here I'm, yeah, okay, that's why it is. Oops. Oh no, I did. No. I'm recompiling in Emacs, which means I'm recompiling with test enabled. Interrupt this compilation. That just means I'm gonna have to recompile more. Okay, I don't care. Let's go back here. And now we wait. But hopefully that was a mistake. Okay, so that seems to be at least going through. I'm gonna just do one quick thing in main. Print a new line between each module. So just it's a bit more readable. Okay. Module foo here that has a bunch of things. Oh, also because there's a bunch of trace, of course. Module bar, which has a bunch of things. So here, what we're trying to see is the type of this function f2, what does it resolve to, knowing that we know here of this nonsense. The type of f2 here is that it's a b4, and the first argument is a b4, and the second argument is an int. Sorry, no, it's a b4 of int, followed by a b4 of a4. It is a b4 with two arguments, the first one being a b4 of a4 and the second being a b4 of int. No, the other way around. Let me actually just copy this and look at it in some Scratch module, like just to have a look at what it is. It is a function declaration. Okay. The fun type is this. The function body is empty because for now we're not resolving this. Okay. So it is a b4 that points to okay, an int. Oh, this is a list within a list. I need to be careful. Path info, there we go. Just manually aligning this just because I want to test that this result is what I expect. Okay, and then the second path info. You're very annoying. Trying to align things for me. There we go. Okay, that's a perfect. So the type of our function is a B4 struct with two parameters. The first one of which is a B4 parameterized by int and int, and the second is B4 parameterized by A4 and A4. Does that match what we started with? We started with a B1 A1 int, which translates to a B2 int A1, A1 resolving to A4 as previously established, which means that it's a B4 of B3 of this first argument, which is now int, and B3 of T2, which is now A4, and each B3 is just itself a B4, so it's a B4 of B4 T1 T1, which is int, And a B4, the second argument of the B4 is itself a B4 with A4, A4, and that's what we see here. Okay, so our type alias resolution works and our variable substitution works. Okay, progress. Whew. Now, there's one thing I want to showcase that is broken, and I want to showcase. I'm gonna comment this out. Why? There we go. I want to showcase. Where would that be? We're going to show it here. Type C1 of T1 equals C2 of T2. Type C2 of T2, sorry, T1 here, equals, and now I'm going to use B3 of T1. This is wrong because T1 here will not be in scope when doing the analysis, but with the bug I found earlier, this, if C1 is analyzed before C2, this will succeed because the scope will contain a T1 that points there that should not be there. And depending on this, it will either resolve to something wrong or will contain, will result in a internal compiler error. What do you mean expecting? $417. Oh, yes, of course. Internal compiler error. There we go. Because this should say that it's T1 is not in scope, but we have an internal compiler error at the moment because of the bug that I identified before. Now, what does that mean? That means we need to go back to analysis, and I need to be able, in this analyze declaration method, I need to reset the scope to what the base scope is. So here, when I'm doing this local info location stuff, I need to reset the scope as well. Because each declaration should only be analyzed with the scope, the top level scope, and nothing else. Okay. So I guess that means wait. Yes, of course. The names is in the reader, which is not great. Well, it makes sense. I'm just gonna add info top level names, which is gonna be the same thing here. Which I'm gonna change. Then here in the top level of the analysis, I'm gonna start. There is a local in here somewhere. I think at the top level here. There we go. This is gonna be not info names, but info top level names. There we go. So that's the scope at the top level. And whenever I start analyzing a declaration, regardless of what it is, how do I chain? I think with just a dot, the classic function composition. I guess I'm gonna write it as a proper function then. set scope and set scope. Okay, update scope. No, set scope is fine. Set scope is a function that's going to take the previous context info, or whatever it's called, analysis info, and it's going to return a modified version of it, in which we are going to change info location to be pointing to the declaration location. Here's the thing, here's the location that we're currently analyzing. And the info names will be reset to the info top level names. Okay. This is probably not going to compile on the first try. There we go. Wait, what? There's an error in there. Oh, of course, yes. This analysis info will require more stuff. Yes, this is currently the map for names, which is going to actually be empty. And it's the top level scope that is going to be initialized with this. Okay. Which means I need to make sure that at the top level here, when I do my local to initialize, I'm modifying top level names. Yes, perfect. Let me check that info names is used in resolve path here, which is fine. Perfect. Okay. And now info top level names. Yes, that is correct. It needs to have the underscore here. Nope, nope. I'm recompiling with tests now. Oh well. At least if it doesn't compile, I'll be able to check to fix this in editor. But now it compiles, which means I'm gonna have to rerun things in the terminal. That's fine. Just a second, I changed something. Oh, there we go. I guess I could just not run with tests for now in my editor to avoid this back and forth. Because compiling the parser is extremely slow. There we go. Okay, and now instead of an internal compiler error, we get a name not found. Again, our error reporting is horrible, but now we have fixed our internal compiler error from earlier. Perfect. Okay. Trace show. I'm going to remove this trace show for now. Okay. So now we've done type substitution working correctly. That's a pretty big step. We fixed the analysis of the struct. That was wrong because I was not doing this properly. I could probably try to deduplicate this, but that there's like only two places that where we do it, and they're just like side by side, so that's probably fine. Okay. I guess we can go back to making progress on doing the rest of the analysis, which is constant and functions. Aha, yes, that's something that I was stuck on last time. This is going to be not a nightmare, but it's going to be complicated enough. It's, I think, worth doing right now. Here, I was saying, well, when I have resolved the type of something, and I have resolved the type of an expression, I can compare them. The problem is, I was using this equality thing. That doesn't work because I simply have not defined that type. Well, the type that is used here to represent the types has any equality value. That is an equality constraint. But I don't think I want to do it with the equality constraint because I want to be able to say those two types are compatible regardless of whether they are the same or not. And which in our case is the same thing because we don't have any case where types can be substituted, I think, because we have no implicit cast, we have nothing of that nature. So there's not anything complicated to do here, except generate types. My strategy for generic functions is going to be based on C++. I don't know how Rust does this, but like C++ is the model I'm familiar with, which is basically each module will export the list of instantiated generic functions that it requires. As in, if there is a module foo that has a generic function and a module bar that uses the generic function of foo but with actual types, then it needs to be instantiated in the symbols exported from foo, basically. That is the gist of it. And therefore, I will have to instantiate so that, okay, as part of the stuff exported by this module, here's a version of foo in which the type have been replaced. And I will do some of the type checking when doing this instantiation of a function for a given type. The problem is we cannot fully. We will need to basically retraverse the expressions and check that they are fine. There's a lot of places where we're not going to be able to decide because, well, it's going to depend on what the type T ends up being. So I will have to be smart and have the type checking here in some of those places know when to delegate, like, oh, that's a type parameter. We don't know yet, basically. Okay, so well, that would be the not this, I guess. I can try to start writing this, and we'll see how much progress we make. There's a bunch of stuff I'm going to get rid of at the bottom of this file. Because that's all very old stuff that is no longer required. Perfect. I'm just going to write it here for now. Matches is going to be a function that, given a path info resolved and a path info resolved, will give me. Do I want to say that it just gives me a boolean, and that boolean just says true, they match, when I can't decide? As in, basically, this tells me false if and only if I can report an error because I have enough information, and just returns true in any other case, basically, when I cannot decide. I think that's the correct approach. We can start with that and see afterwards anyway. Is there Google for the rescue? Is there the flipped version of dot? Wait, I don't need to do that actually. This is just uncurry. Oh, this is just curry of this, which is there we go. Curry of case, which is going to be a function that takes a tuple of two arguments and makes it into a function of a tuple of two values and make it in function in two arguments. There we go. And now, except that's not true. Okay. Because I only want to compare the names and I only want to compare the arguments. So I want to do case of path name P1 and the path name P2. And here there's not that many options for now because there's only 4 kinds of names that we recognize. Although there's going to be more later, so we're going to have to change that later. Actually, since there are names that aren't types, I'm going to make this explicit that this is type matches. So when we have two names that point to a specific identifier in a specific module, then do they match is fairly simple. It is M1 equals M2. They are defined in the same module. And I1 equals I2. They are the same identifier within the same module. Since everything is resolved will point to the specific location place where the thing is declared. And match an argument match. Okay. If we end up with two built-in types, built-in type T1, built-in type T2, then those match if and only if T1 equals T2 and arguments match. And here's the trick. If I have a type parameter, I think regardless of what it is, I have to accept that it matches. Like, is T the same thing as U for a thing that has two type parameters T and U? Well, if I try to instantiate it with two type parameters that are different, it will never compile. But in the meantime, for now, yeah, that matches. It's fine. So and likewise, if on one hand I have an int and I have T, that just means T will never be able to be anything else than int, which I guess could be a warning. But I think is fine. So I think for now, regardless of what the type parameter is, and regardless of what the second argument is, the answer has to be true. It matches, always. Likewise, if we have anything first and a type parameter second, it always matches. But if neither of them is a type parameter, if neither of those two names is a type parameter and they're not matching, which means we have a built-in type with a top-level declaration or something, then they no longer match, and any other case is false. And how do we compare that the arguments match? Since we're never gonna accept, we're gonna call this for anything that for top level declarations that have the same, I don't have to check length here, it will be checked already. And arguments match is gonna be simply an AND of zip with type matches of path params p1 and path params p2. So that's, again, our type system is fairly simple. There's no coercion. There's no, like, at this point, it's all resolved. So I can just take that, like, yeah, it's the same, basically. Okay. So now with this, my constant here, I can say when not resolved type matches, I can do a error unexpected error wrong type, I guess. Diagnostic error wrong type. And I guess what will I need there for this error? Which is, this error type is absolutely horrible. The proper error type is probably going to be a struct that contains the location, information about what we were trying to analyze, like full stack of everything, and the enum of this diagnostic enum. For now, this is good enough to get started. And I expect that I will just want to have path info resolved, which is going to be the expected type, path info resolved, which is going to be the actual one. So error wrong type. The expected is the resolved type, as in the one I have declared. I have said that this constant is of type int, therefore this is what I expect to be true. And in fact, it was given to me as this expression here, therefore it is wrong. Perfect. Now, I can go back to this process of, actually, since that compiles, I could try, there's a bunch of undefined here, there's a few parts of the expressions that I have actually done. I think int literals, yep, except I do still have an undefined here. Okay. So what am I trying to do here? Why is this pure type expression undefined? Oh, is this because I don't know how to represent the type of int? That's probably what it is. Typed expression, it's defined as part of the AST. Typed expression. Yeah, it's just a resolved expression and a path info resolved. So let's go back to built-in. I still haven't done the declarations for built-ins. That's something we're going to do at some point. Because at this point, I still can't type check built-ins properly. But that's not something I'm going to do now. Int path is going to be a path info resolved. And int path is going to be path info which points to the built-in type int and no type arguments. Which means I can rewrite this as being the path name of int path. Okay. Which means here in my analysis of a constant, in the case of here a literal expression, I can say int path. Okay. And that should be enough for me to be able to go back to test, main, I guess. Remove all of this nonsense. I'm gonna hide bar that I'm no longer gonna import. Or foo for that matter, I don't think I need any of this. I will only say, hey, I have a const x which is an int. Actually, would I want int to be lowercase? For now it's uppercase. It's fine. Which will be for now 3. And this should work. Variable not in scope. Okay, that means that here in analysis I need to import arrays built in. That's because I am giving a tuple here instead of what I wanted to do, which is to give 2 arguments to zip with. There we go. Okay. Input of debug trace is redundant. We love to see it. Perfect. Next. Okay, that compiles. Here, let's run main, and this should work. X is indeed a constant named x with type, which is built-in type int with no arguments, which is a typed expression that is an int with the value, which is an int literal expression of 3. Okay, perfect. And now, if I change this to instead import foo in, and I say here that this is an A4, I will need to compile foo first. Okay. Error wrong type, expected foo A4, got built-in type int. Perfect. So this very basic type comparison seems to be working. That's great. Now let's go back to actually doing the analysis of a expression in the context of a constant. There's probably going to be a lot of overlap with the analysis of a constant an expression in the case of a function, but there are going to be some differences. Specifically, function calls are not allowed. Like there's a bunch of things like this where I have to see how much I can deduplicate the code between the two of them. Okay. So, what do I want to make progress on? Because there's so many things to check here. I think it would be nice to try Yes, that's also something that's going to be different here. All constants should be able to fully evaluate at compile time. So there's a lot of things we're going to be able to do a bit differently because there should never be any point where the type is not known. And constants do not take type arguments. They don't have type arguments. That's not something that exists. Therefore, we should be able to simplify everything at any point. So, okay. If I encounter a negation expression, I resolve it. And the inner thing must be an int literal expression. If it's not, I guess I can do this with like when t different from int path, as in the type of this thing is not an int. Wait, negation can also be Boolean. Because I think I'm doing the same thing that Rust does, where I negation, let's see, a negation expression is either, yes, it's one of those two. Okay. So let's have a look at t of, well, I can't do this, but I can do if t equals int path, then do something. If t equals bool path, do something else. And otherwise, report fatal. Aha, I'm going to change my diagnostic. Wrong type will take a list of valid types in the context, because there can be more than one. Which means here I'm going to need to error wrong type resolved type. I'm going to need to change in my batteries included built in. I'm going to add Boolean. Oops. Which is going to be the same thing. Boolean. I think Rust names them with lowercase. Let's see. Rust Boolean. Yes, it is lowercase. Do I want to be consistent? Probably, since I am using Rust as the reference for the syntax. Then I think I'm going to make int doesn't exist in Rust. It is always like specific. So I guess mine would be I64, I guess. But I like just being able to write int. So I'm going to say it's int. I'll probably have string as well at some point. But that string will probably be a type alias to vector of character. I guess I could add character already. But vector is going to be a nightmare to implement, so we're not there yet. Okay. Aha, but by doing this equals equals, I am going to need to do the thing I was trying to avoid, which is that path info is going to require an equals instance. And that is going to be annoying because for this to be equals, it needs the name type to be equals, but that's not the end of the world. I think the only place where I need this is there, and therefore I think this is enough of a list of constraints for now. Let's go back to the analysis of things. So, in the case of an negation expression, I resolve the inner expression. It must resolve to either a constant, a compilation time known value of type int or boolean. Otherwise, I can report a fatal error, which is wrong type, error wrong type, which is a list of types that would be valid, which is int path, bool path. But in fact, the one we found was t, which is not either of those. And now, in the case of, I have found that the type of this expression is int. I can do a case of the resolved expression. If it's a int literal expression, that's perfect. I can return a pure typed expression with t and an int literal expression with minus x. Otherwise, this is going to be an error that says not a... Can this happen? Or is this an internal compiler error? Because it means I have tried to resolve the sub-expression in the context of a function, and I did not end up with a literal value. This can this can happen. This can happen. If... No, I don't think it can actually, come to think of it. No, it can. It can. If I have, for instance, a struct expression underneath, which is fine, which is a valid thing to have. Oh, but it would be found by the fact that the type is wrong. If I have something of type int, I don't think it's possible for this to happen. So I think I'm fine calling it an ice for now. Which means I can do the same thing in the case of a Boolean expression. Okay, and that's our 3 cases for negation. And now I think all of the others. No, addition actually works on strings. And do I want to do character addition? Like, would it make sense to say C+1 or something? I don't think so. I think I want to have that conversion a character to int and then do +5 or whatever, and then convert back to character. I don't think I want to support arithmetic on things on characters. I think it makes no sense. However, it will exist on strings. Concatenation on strings will be a valid thing, or on vectors at large, but I don't have that yet. So I think for now I'm okay with defining this on int, but I probably want to do addition differently from the others because it's going to be one of those that will be valid on other types. So I analyze the 2 sub-expressions t1, t2. When not match types. How did I call this thing? Type matches. There we go. When not type matches, which I guess it's an unless. unless type matches T1, T2, I can do a report fatal. Is that correct? Is the problem that they don't match, or is the problem, or I'm gonna have to do something anyway to check that they're both int. So probably. Yeah, I probably don't need to do that. I can probably do instead. So if the first one is an int literal expression and the other is some, let's do this way. If R1 is an int literal expression, I can do something. Otherwise, I can do err wrong type int path and whatever T1 is. And in the case where it is an int literal expression, I can do a case R2 of, have the exact same thing here. And here I have two ints x and y, and I can return pure of a typed expression, which is an int path. I don't need to use T1 or T2 for this. And the value of which will be an int literal expression of x plus y. Okay. And I'm going to keep addition separate because it's going to be one of those where I'm going to have to support other types, but I can do a binary int expression thing that, given a way to combine two ints and given a typed expression and a typed expression, returns a maybe T analysis M type expression. arg1, arg2, or e1, e2, I guess. Actually, no, that's even incorrect. I think at this point, this is a expression passed, a with location expression passed, and with location expression passed. And this is going to be basically exactly what we've done here. The only difference is I'm going to keep addition separate because, again, plus will be overloaded to other built-in types when we have other built-in types. For now, this is going to be used for any of the others, and this is going to be resolve E1, resolve E2, case R1 of like, and if any of them doesn't match. And then finally, the only thing is here, it's going to be fxy instead of plus. Which means now, in the case of a subtraction expression with E1 and E2, oops, this is going to be a binary int expression with subtract E1 and E2. A multiplication expression is going to be the exact same thing. Except it's going to be not subtract but multiplication. Division is going to be the same. I would need to check for modulo if the Piètre modulo, which one it is, if it's mod or the other one. I never remember. Okay. For now, I'm gonna be using div and mod, and we'll fix that if it proves to be wrong. Is it this one? No, it's this one. Equality. Equality is not a binary int expression, so I can't use that. Because a bunch of other types will be comparable for basically every type that will be comparable for equality, as long as every type will be comparable for equality, because it will be a matter of just checking that the values within are the same. Same thing for difference, I guess. So I'm not going to do that yet. Comparison will probably work on strings as well as int. So let's not do that yet. For booleans, I can do binary boolean expression like this, and an or. This needs to be named E1 with E2 as well. Range, I'm not going to do this evening, because range requires doing vectors. We have not even started to do vectors or anything like this. Assignment will probably be wrong in the context of a constant. I think that's not something I want to allow. So I think assignment is just simply not something we allow in a constant. And as a result, I think all of those is very much, yes, exactly, a report fatal on all of them. Okay. So now I need to test, I need to do binary bool expression here. Oh, I don't think... Oh, wait, no, I know. I was going to say, how do I handle Boolean literals? And the answer is they're here. I just need to do here a bool path and car path here. Perfect. Okay. And so for Boolean expressions, this is just something that takes, this is int to Boolean. Oh. Let's go. There we go. It's going to be the same thing here, with the big difference that I check that at both levels they are Boolean, and as a result, all mentions of int here replaced by Boolean. Okay. Fix the alignment here, and there we go. Okay. Let's try to compile this. Okay. Not used. Yeah, I suppose on all of those. I mean, if it's the only error we get, I am not too unhappy. So unused matches happens fairly late in the... Okay, that builds. So now I will want to try... Let's go back here. Let's go back to main. So what I want to try here is, as a result, if I do 3 plus 4 times 5, which is also a way to test plus 1, let's do, which should be a way to also test that precedence is working correctly, I should be getting 24. I don't need any of this. I can build with just main. X is an int of value 24. Perfect. And let's try with parentheses, and this is now times 2. 24 times 24, that feels... That would be 20 times, so that's 480. Yeah, that feels plausible. Okay. That seems to be working. Const y is gonna be a boolean, and it's going to be not. 1, 2, 3, 4, 5, 6, 7. So it's just the same as 1, and it's gonna be true or false. Aha. This doesn't pass, interestingly, because I forgot the semicolon. And this is false. Is that what I expect? It's an odd number, 1, 2, 3, 4, 5, 6, 7, of something that is true. So yeah, that makes sense. Okay. As a result, now this should be true. Yep. Okay. Perfect. I guess there's one downside to the way I've done it with... I've done the same thing as Rust, and there's a downside to this, which is I cannot distinguish between, at least with my current representation, I cannot distinguish between the two negation operators. So if I do this instead, 1, 2, 3, 4, it should be false. Yeah. So minus an a boolean gives me the other boolean, and not of a int gives me another int. I guess the only way to solve this would be to keep the well, the only way. No, two different ways to solve this would be: first, have a different negation representation based on the thing used, or it would be to keep the actual tokens that I match and check when it's a negation which token it was, so I can see how I want to handle it. And I think I want to change my AST, because I don't think I want to allow this. So I think it's time to change the AST and to distinguish between int negation and boolean negation. I break a bunch of things, which is fine. Which means I need to change the parser. That's a boolean negation expression. That's an int negation expression. There we go. Which means that back to the analysis here, I need to split this negation expression handling in two. because this is the Boolean one, and this is the int one, which means here I don't need to. So now I can do this as unless t equals Boolean path, report fatal this, and it must be a Boolean. There's no way an int can be accepted here. And then I move to this case here. And I can move this here to be the same. Except I'm going to do replace all mentions of Boolean with int. And this is no longer not x, and not x, this is minus x. Okay. I guess if I wanted to avoid this error here, I could instead do this. And if it is a typed expression, I can't do a case on the type t and the but I can do this. T and bool literal expression x when t equals Boolean path, then it is this whole nonsense here. Otherwise, anything else, if it doesn't match this exact pattern, report fatal error. There we go. I can do the same thing here and replace again all Boolean with int. There we go. Okay. That is quite some progress. I'm gonna make sure that this compiles now that I've changed the AST for negation. Oh, there's a bunch of things that are beginning to be broken. Well, there we go. Let's go for them. This is the pretty printer. And that's a thing I had already noticed at the time, which was, well, when I'm pretty printing an AST, I'm not going to be able to decide which of the two symbols I'm using because both will point to the same thing. Now I can fix this. Oops. Compile here instead. Is there anything else that's going to be a problem? Annotation expression plated. Yes. Could I actually use plated for... Could I use plated for this resolving expressions rather than calling go manually the way I have? Because I have defined plated and expressions really for that purpose. Could I use it there? I think I might. I'm just going to check how plated works again. This is a int negation x bool. And I just need to bring him back within here. There we go. And open the plated documentation while this compiles. Control lens plated. There we go. Okay. The parser seems to be compiling. variable and its scope. So there's a few things that are broken. Ah, yes. Here, I still need to match that it's a typed expression t with anything else, so that I have access to the name of type t to be able to report it here in the error wrong type. Okay. Oh, this is the actual implementation of Piètre, not what I wanted. Okay. The problem is Piètre used with like self-similar thing, and here I'm transforming them. I don't think I have a good way to do this. Because even transform M will replace with some. Yeah, I don't think there is a good way to do this with Plated, sadly. At least not for this thing that I'm doing at the moment. Okay. Yes, this is back to being this. Okay, that compiles. So now we've changed the AST ever so slightly, but it should not. Do I want to? I want to run the tests on this one, which means recompiling a bunch of things. But I do have tests of the AST. I have tests that generate random AST and like print them and pass them again and everything. Now that we've made changes to the shape of the AST and the parser, I want to run the test again, just to be safe. Oh, it's late. Ooh, I should probably stop soon. Okay. Of course, the tests are broken. That's not that surprising, but that is, of course, something we have to fix. Int boolean. Boolean. Shrink, that's fine. And do I have for arbitrary? Yes, here I should probably negation. Where are you? What? Oh, negation. There we go. Would that be enough for the arbitrary instances to be fixed? And for, I guess we'll see. Okay, fail. Test output. It's a golden test. Okay, so golden test. I'm not too surprised. I probably have test integration. I think passing basic PI. Yes, here I have the x is minus 42, which before with the weird thing was always rendered as this, and now can be properly this. Test output was different. So that's is it because I've removed a space or something that shouldn't have been removed? I'm just gonna remove the file altogether and just rerun and see what the difference is. Test integration passing basic.golden. rerun the test, which regenerates the golden file. Perfect. And now I can do a git diff of this file. What does that mean? It didn't change. Oh, because I have a git ignore on it. Well, that's silly. Yes, it's the new line at the end. It's the new line at the end. Okay. That is where it is. Okay, so I don't care. That's not a big problem. And now the tests pass. And yeah, perfect. Including the round trip ones. Perfect. I'm gonna stop soon, I think, but maybe I can make a tiny bit more progress on some of this. This is a bit unwieldy. If I go back here, that's a bit better. There we go. Because their path expressions is going to be interesting. Because I'm going to need a with constant, which is going to be the same logic as with type and so on. Because the only kind of expression of path I'm allowed to reference in a constant is another constant. Yes, because the only other thing would be a call expression, which is not allowed. So that's not there's no problem there. But there could be a structure, but structure expressions are a specific thing for which I can do a resolve type or resolve struct on the structure, which is therefore something different. Therefore, path expression here, I can probably just say that this has to be a constant. And the resolve constant will have to do the proper analysis of it and will detect cycles if cycles happen. Oh, I haven't tested that actually. I'll test that. So I will need a resolve const. Resolve const. And I guess I'm going to do the thing I wanted to do, which is, in the case of a const, I really don't care. No, I care about the path info for one thing. I want to be able to check that the type matches. Well, I guess the type, if I do a typed expression, it will be the path info. So I think I want this to be a typed expression. I want that to be a typed expression. Resolving a constant, I just need the type. Yeah, okay. So I'm going to need to get the type the path. Which means I'm going to need a go function like this, which is of type resolve callback. In the case of no declaration, is that something that makes sense? I'm trying to resolve the path. No, I think that does not make sense. Because again, the only case, I think I really want to fix this thing. I want to always have a case where we have a declaration. But I think for now, this is going to be a report fatal and defined. And in the case of a declaration, then if it's a type alias, that's just not correct. It's going to be a report, not a constant, I guess. this is going to be the only case that I will want to handle. All of the others are going to be enum struct. All of the declarations are going to be that is not a constant. Which is not something that exists yet. I'm going to need to introduce it in my diagnostic. And I can probably do the same thing of having the declaration resolved here to be able to say what the declaration was in the error message. Okay? And now what do we do with an actual honest to God constant? And I will need to do the proper resolving of it. The problem is, can I change? Yeah, of course. I could have done this the whole time. I can parameterize resolve callback. Resolve callback is something that for a return type R gives me this type R in the thing. So resolve path for some resolve callback of R gives me R here, which means I can choose what each thing returns, and which means this is just a resolve path go path info, and here this is a resolve callback of typed expression. There we go. That's going to solve my resolve struct from before. And resolve type is a resolve callback of path info resolved. And perhaps even, let's be bold, a declaration resolved. Wait, no, I can't do that. I can't do that. Because I am not guaranteed to have a resolved declaration for the thing. Okay, let's go back to this for now. We'll do struct differently at a later point. Okay. Okay, so here, when I find the constant declaration, I can do the thing I was doing for the type aliasing here, which is I resolve the declaration, which is the recursive thing and will error on cycles. Path name declaration, there we go. And this is the ugly thing where I have now to check again that this is a const declaration. Have a bunch of those, which is when I'm doing lookups on things that should not fail, which is always a bit annoying. I'll have to try to see if I can reduce them later. The way to resolve this would be to have like a variant of resolve declaration that works on all the different types, but does the mechanism properly, which would not be monstrous, but something I have not done yet. But at some point, if I do a pass of like remove all of those ices where I can, that's definitely something I'm going to do. Now, I have resolved the const info, so I have the const info now, which is the resolved info. And I think the only thing I need now is to return simply to return, if I look at the AST again, const info. This is going to be the typed expression. So what I need to return is the const expression of this info. Okay. And this is resolve const. Which means now, and I guess resolve struct, I can do this to be the struct info like this. That's perfectly fine, because now I can do exactly that. With the difference that this is, I can do proper errors for all of them. This is not a struct. So now I can do some proper error handling. This is not path name, this is the declaration. Oh, that's a problem. That's not gonna work. I have no guarantee that this declaration here is resolved. That is frustrating, so I think it needs to be a name again. So this cannot be the declaration, this is going to need to be the name, which I have access to as being path name. Okay, I can do the same thing for constant here. And for resolve type, I don't have that problem. Okay. So struct here is the one I can change. There's a bit of duplication between those two functions, which is a bit annoying. But that's not the end of the world. I can always deduplicate later. And here I return path and the info. I guess also the difference here is that's not true. It's always going to be the resolved info. When I resolve the structure, I will need to fully resolve it. Which means here I can do this fully resolved info. Which I guess for structures is always fine. There's not any problem there. And I need just therefore to check that this is a struct declaration. Okay. Resolved info, and here I return resolved info. Okay. Okay, that should be fine. The only problem I see here, this is wrong, because in the case of a type alias, I want to resolve it. But then I want to. What is. I almost want to generalize resolve type and resolve path to take a path info regardless of what it is. Because what I want to do is, in the context of resolve struct, I want, in the case of a type alias, to then, with the result I get, to go recursively, basically. Because what I have here is the path info resolved. Yeah, what I would like to do is a resolve path recursively. That's what I want to do. But resolve path does not work like this. But it could. There is no reason for it not to work like this. It could work for any path info p like this, with one condition. And that one condition is I need to be able to do a resolve type on the parameters, which means I need to move to resolve type quality resolve is not great. Parameters, which will take a path info p and return a maybe, yeah, that. Resolve type params is going to be, in the case of past, a very simple resolve type. In the case where it's already resolved, it's gonna be pure. Okay, and now resolve path here, I can do a resolve type params of p on those things. Not sure this is going to work on the first try, because doing again some shenanigans, but there's none of this annotated type, non-injective type family. We should be able to like add type annotations until this works. And now, as a result, I can resolve recursively, which means I found a type alias, I get its declaration, I get everything. Now I can resolve this recursively to make sure that at the end, what I get is a structure, and at the end, I can return the proper resolved info of the structure. Perfect. And here we were doing the constant, and the constant is this thing where, perfect, anything else is not a const, which means here I can I can do this, and I guess the type of this is a type expression, which means this is just that now. Okay, let's try to compile this, and then I'll do more tests of definitions and circular definitions, and then I'll stop it because it's getting late. I suppose I will. Let's try with that. Wait, do I have? Was so many of my errors just because I don't have rank n types enabled by default? But does GHC 2021 enable that by default? Come on. GHC 2021. rank and types is okay. Okay. Okay, where was I? Error name not found path name. That makes sense. I cannot. That makes sense. This whole thing is predicated on I need to find the name of a thing in the context, which doesn't make sense. Okay, so I have to give up on this. That's a shame. Which means this is just a traverse resolve type, which means I have to remove from my analysis class resolve type params doesn't make sense anymore. Shame. And that means that in resolve struct, rather than having to do this, that means I have to do I have to redo this, basically. I have the actual name. Actually, now that I have the resolve callback alias, maybe what I want to do is introduce a new function, resolve name, that given a resolve callback of R and a name resolve is just a name, we'll return all of this. Process declaration name. Okay. I just need the resolved path info to this, which is I don't even need that. That's because the name is part of it. That's a path info resolved. Resolved path info, and as a result, name here. That is the path name of the resolved path info. Okay, which means here this becomes a simple call to resolve name with the callback called process declaration and the path info. Now, if I have already a callback and a name, I can just reuse this, which means in my resolve struct here, this is a bit duplicated. I'll have to probably do something better than this, like deduplicate some of this, because I don't want the checks to be performed twice, because if they are, it means if there's a bug in one of the, like, I repeat myself here, and I don't want to do that. Here I can do a resolve name, go result path info, and that should be fine. Okay. Couldn't match. Path info resolved. Struct info resolved. Okay. Ah, yes, I have a name conflict there. There we go. Aha. So here, this is probably a case where like no declaration found as an error. So I can probably do a not a struct. I'm gonna move all of those to the top. And all the errors at first. Okay. Defined but unused path. Perfect. Defined but unused info. That's interesting. Yeah, I suppose if it's a constant, I don't care about the actual info. I'm just going to do a resolve declaration anyway. Yeah. Okay. Likewise here. That makes sense. Let's compile this. It looks like it compiles. That's good. Which means I'm probably going to stop here for the evening. But before that, we have a few more tests we can do. I want to go back to main. Because what I want to try here is I want to have type A equals B, type B equals int, const x int, well, A is y plus 5, and const y, which is an int, is 3. Which means we're testing that int equals a because a equals b, which is equal to int. We're testing that a constant x can make reference to a constant y. We're testing a bunch of things there. Okay. A is a type alias that points to built-in type int. B is a type alias that points to built-in type int. Y is a constant of type int of value 3, and x is a constant of type int and value 8. This works. Now, what I want to test is my cycle detection mechanism. For instance, if I say type b equals a, what happens? Error cyclic definition between top level declaration a and error cyclic and top level declaration b. I'm getting 3 of the errors. I'm getting cyclic definition for main of A, B, and A. I wonder why that is. Probably because I've been trying to like look at them separately, and I don't deduplicate errors. I probably should short circuit a bit more aggressively in case of cyclic definitions, and therefore not try to do this the other. I should probably have like a way to flag it that I've already like that some of the things are already an error, and whenever I encounter a attempt at defining a declaration that's something that's already labeled as wrong anyway, ignore that and therefore not report any errors. But at least we're not running infinitely. We are indeed finding error cyclic definition. And if I fix that back and I say, however, that y is x plus 3, then I should get error cyclic definition. X and y, they are cyclic, therefore they cannot be defined. Perfect. So it is possible for a constant to make reference to another, but only if there is no cycle. Okay. That looks pretty good. We've also checked this. We've fixed a bunch of things this evening. We've fixed all of the type resolution with the new type class, which is a bit inelegant. But now we have the thing with like the different resolve things can give a callback that does the proper thing no matter what. And we've finished doing the resolution of type aliases, and we are finally. Do I want actually to make one change? Do I want? Let me think about this. Do I want to remove type aliases altogether? Because I could, when I resolve a type alias, like I analyze the type alias in a module and I'm exporting this as the module, I could not export it as a type alias, but as the actual underlying type. Which means I could associate to the name the proper declaration. But I would not be able to do type substitution. No, okay. I have to keep the type alias declaration because I need to perform type substitution at a later stage. No, okay, I can't change that. Okay, okay. But does that mean, however, yeah, I'm not looking at the declaration, I'm looking always at the value, which means whenever I'm resolving a type, I will always be resolving. I guess I could do the same thing here that I'm doing for structs, which is to include. No, I can't include the corresponding declaration because there will not always be a declaration associated with it, because I can't guarantee when I'm doing a type alias that I have actually resolved the thing. And often when I do a resolve type, I don't want to resolve the thing because I want to be able to type check without actually doing cycle detection. Okay, I think the next big thing, I'm gonna have to finish next time, now that we solve a bunch of those problems, finish the analysis of a const value, because a lot of stuff has been done. I guess now cast expressions are one of the few things left to do, and a few field access expression, call expression. I can probably like introduce a diagnostic for each of those. Or I could decide that I've done enough for constants for now and move on to enums. There's a big thing for enums that I'm going to need to do, which is at the moment, enums are not included in the scope, which means if I have an enum color with like red, green, blue, and I'm making a reference to red in an expression, that is not going to be identified. Aha. That is an error here. I'm doing a resolve const here, and that is not correct. Unless I consider that enum constructors are constant. Yes, I think that's the best approach. Red is a constant of type color if there's an enum named color with constant red, green, blue. I think that's for the best. Basically making fake constants as part of my top level. Yeah, I think that's the proper approach. Okay. But that's something I'm gonna do next time. I think that's enough work for today. I'm still not at the point where I can write proper tests. I wish I had a way to write actually like tests for like, but until I have until I have more code here, until I have more analysis, until I can like analyze actual functions. I think trying to write tests for all of the error paths doesn't make a lot of sense. I think we need to make more progress before we get to that. Hopefully on Thursday we'll get enough progress done that we can do that. Yeah, I think, yeah. On Thursday, try to do more on the constants. Try to see if there's more things we can do there. Do the enum declaration thing and move on to analyzing functions. Okay. In the meantime, I'm going to stop here for the evening. Thank you for tuning in, and I'll see you on Thursday.